Good afternoon, everybody. Welcome to Tuesday afternoon of Chem 170 with your host, me, Dr. White. And hi. All right, couple important things I'd like to talk about. First of all, the labs. I sometimes mess up when they're due, but they're always due the next lab period. But I give you extra time after that. Don't tell anybody I'm nice, but I give extra time. Also, let me remind you, when the schools close, I'm not teaching. I don't do office hours like yesterday. Do you, unless you're getting paid a lot, do you work on Thanksgiving or New Year's? No. Same thing with me. Same thing with holidays. And on the weekends, I try and check it twice, my email, but sometimes I can only get to it once. And I don't work for this school 24/7. I try and respond to all emails within 24 hours. And I just wanted to make that, talk about that briefly. All right. As you know, I post the scores and you each should have gotten a email with your individual scores for test number 2. I'd like to go through test number 2 now, and then afterward, I will continue on. And today that means the carboxylic acid and ester problem set, amines, if we have time, which I think we should, and then our lab esters. All right. I don't know about you, I'd have a question. Well, what grade am I getting? We've already had 2 tests. We're almost finished with the semester. We only have 3 weeks left. Wow, it's gone fast. Well, let me show you the following. There's 2 ways to calculate your grade in this class. Someday I'll learn how to spell. Let's assume X, but not assume, the sum of 2 tests divided by number 2. If X is 90 and above, look at my syllabus, it's an A. If it's 80 to 89, it's a B. If it's 70 to 79, C. And 60 to 69, D, less than 60, F. That's method 1. Now remember, I dropped the lowest of 2 tests. By the way, this is assuming you're handing in your labs. Hand in your labs, please. And Y is equal to the highest score. You should have your test score. And that means pick test 1 or 2, whichever is higher. If 90 and above, you're getting an A, 80 to 89, B, 70 to 79, C, 60 to 69, D, less than 60, F. And that's in my syllabus. And that's how you can determine, assuming you handed in all the labs, or should, what you're getting in my class right now. Now, any questions? Speakers on, speakers on. When I first started doing Zoom, I have two huge speakers up here. I forget to. All right, whoever asked for a live transcript. Wow, look at the bottom. Can you see that? Let's see how it does in organic chemistry. Ketone. Oh, I'm impressed. Oh, let's say carboxylic acid. Well, carboxylic acid. Nope, doesn't like carboxylic acids. But anyways, it's on. Enjoy. All right, I gotta stop watching that. It's interesting. All right, let's move on. Well, before we move on, I've got to open something. Let me remind you, as soon as I put this up on the screen, if ever whatever I put on the screen is too small, let me know. I can always make it larger. Can everybody see the the transcript at the bottom? I don't think I have control where I can place it. All right, let's do the carboxylic acids and esters problem set. Let me remind you. Carbonyl with hydroxy group and R. That's a carboxylic acid. And remember, find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add OIC, and the word acid. No number, because the carbonyl carbon of a carboxylic acid is always number 1. Now, this is an ester. Name it by the R prime and I see a chat question. Let me get to it. Someone asked, am I rescheduling my office hours from yesterday? And the answer is no. There's no class, no office hour. I've got things planned this evening or right after class, so I can't have it today, but I will have it tomorrow. And if necessary, making arrangements and maybe over the weekend, I might be able to meet with a student or two. All right. Ester, name the R prime is named as named as the alkyl group it is in front. And then there's two ways. This is 1, 2, there's 2A, named the carboxylic acid. Used to make that ester. Then from that name, drop the acid in the words letters IC and add to that ATE. The carbonyl carbon is number 1, and you don't need to have a number there. Now, I had a very sharp student a number of years ago in 170. He came up with a separate method to be or not to be. That's the question I couldn't resist. But anyways, name the longest chain that contains the carbonyl carbon, carbon double bond to oxygen, as an alkane. Drop the E and add OATE. And other than when you have a benzene, which that's benzoic acid, B works all the time. At least I've never seen it fail. All right, let's take a look. For carbons, butane, drop butane, drop the E, add OAC, and the word acid, butanoic acid. Now this right here, when R is a benzene ring, UPAC and their infinite wisdom, and I mean that truly, decided, all right, guess what? We're not going to change those organic chemists, and that's going to be benzoic acid. Now, when you have an alkyl group on a carboxylic acid, carbonyl is number 1. And here we have 5 carbons, pentane, it's carboxylic acid, and drop the E, add OIC in the word acid, pentanoic acid, no number, because the carbonyl is number 1. Carbonyl groups rock. But anyways, and we have a methyl group on carbon 4. Now, the thing I didn't mention, I'll get back to my whiteboard. And that's the carboxylate anion. And how do you name them? 1, name the cation M+ as the element it comes from. That goes in the front. And 2, same as ester 2A or not, or 2B. I can't resist or not to be, that's the question. But anyways, that's how you do it. And let's take a look. If we look at F, Na comes from sodium, you should know that. and the longest chain, 3 carbons, propane. Since this is a carboxylate anion, like an ester, you drop the E, add OTE. No, sir. Boy. Look at the transcript. It's done some strange things. All right, time to really mess it up. 2,2,2 bicyclooctanone. Yep, I messed it up. All right, back to me not having fun. All right, now for G, when R is a benzene ring, you can only use method 2A. The cation is from potassium. The carboxylic acid is benzoic acid. Drop the IC in the word acid and add ATE and you get benzoate. Now for an ester, R prime ethyl, 3 carbons, propane, drop the E, add OATE. All right, now remember my special gift to you. And that is on the R group of an ester and a carboxylate anion, I will never put carbons, alkyl groups. On the long R group or short one of the ester or carboxylate anion, I will never put alkyl groups there. It gets too hard. But while I got you face to face, I forgot to do the following. For any of you outside and you just smell the flowers and think, wow, that's esters I'm smelling. Did you have to pick up a bottle of vinegar and look and say, wow, that's got acetic acid. That's a carboxylic acid. Same thing if you picked up a bottle of mustard or ketchup or the relish, especially the green type that glow in the dark in Chicago. Doesn't really glow in the dark, but you know what I'm talking about. And that contains vinegar, which contains acetic acid, which contains a carboxylic acid. A chick acid? See, I said, whoa. Well, so much for good translating in organic chemistry. All right, that's not what I wanted. Still. All right, now, if we look at J, what do we have? An ester. What's our prime? Isopropyl. How many carbons longest chain? 8, octane. Use 2B. And that is drop the add OATE. And there you go. Now, there are 2 common names I asked you to learn. And the first one, which I already used today, and I forgot to mention earlier, I will cut out of the video the test number 2 answers. If you missed it, come to my office hours or email me. We can set up a special time if I have the time. You should know that this is the structure of acetic acid. And you should know this common name and structure. It's an ester, ethyl, but it comes from acetic acid. Drop the IC in the word acid, add ATE, and its common name, excuse me, which everybody uses ethyl acetate. Nobody calls that ethyl ethanoate. Well, I just did, but just to say we don't do that. If you notice, draw the structure of acetic acid. Now let's look at C. How do you know what to draw? Start from the left and move right. OIC acid, carboxylic acid, that were an E, 6 carbons, carbonyl carbon, I always put on the right, you could put on the left at the end, and carbon 2, I have an ethyl group. If we look at, oops, I made a mistake on G. Cross off the 2-methyl, I'll never ask you. Well, let's just look at ethyl hexanoate. OAT ending tells you they're a carboxylate anion or an ester. There's an alkyl group in front, it's an ester. That our prime is isopropyl. Forget about the methyl, hex and OAT, drop the OAT ending, E, hexane, 6 carbons, and there you are. All right, ethyl acetate I just went through. Oh, and I should mention, you should know ethyl acetate is one of the 2 molecules used for nail polish remover. You notice I don't have my nails polished today, but ethyl acetate is one of the 2 molecules used for nail polish remover. They put a little perfume in it too, but essentially it's ethyl acetate. And until they came out with a super durable cure under light nails polish for women, ethyl acetate was the most common. But when they came out with that super durable nail polish that cures under light, hardens, then they found acetone works better taking it off. How did I know that? Some of my Chem 1 students, 70 students taught me that. Huh, look at the transcript. Now, I made a mistake and J just cross off. I'll only keep M as sodium, potassium, or lithium. There I have calcium, it's right, but just cross this off. I won't ask that ever on test or final. All right. Any questions on nomenclature of esters, carboxylic acids, or carboxylate anions? What the heck is NIRES? Oh, looks like the transcript can't do the alphabet. A, B, C. Ooh, it did that right. All right. Back to work, Dr. White. All right, let's look at reactions. And later this week, because a week from yesterday, next Monday, will be test 3. I'll finish up tomorrow and part of Wednesday, means and their derivatives. Oh, coming attraction. I don't think I'll get to it today, but tomorrow, and I won't cut it out of the video, you'll hear about one of the dumbest things I've ever done in my life. Oh, was it dumb? I still think, how could you do that? How dumb were you? You'll find out. All right, draw the condensed structure for the organic product or fractional following. What do we have? Look for what's different. We have carbon, double bond oxygen, hydrogen, carbons. It's an aldehyde. Oxidize it, you get a carboxylic acid. You break carbon-carbon single bonds? No. So that our group methyl is still on the carbonyl. And if I have something more scary or big, it's just an R group, carboxylic acid, this H becomes OH. Now, if I look at this, oh no, I forgot something. Well, whiteboard. if you oxidize this long enough and strong enough with an oxidizing agent, which I don't talk about reaction conditions in this class, but those are important, you can take a primary alcohol and oxidize it to carboxylic acid. And I just realized I don't have any examples. Oh no, bad Dr. White. Let me do one now. And then after the break, I'll let you have some fun. And the question is, what's the organic product or products are the following? What's different? What's not carbon? What's not hydrogen? Ooh, an oxygen with a hydrogen on and a carbon. It's a primary alcohol. This is oxidation. You get a carboxylic acid. This carbon is this carbon, becomes this. Another way of thinking, you start with 3, I better end with 3. This carbon is this one. It'll be double bond oxygen hydroxyl group. And here's the rest of the molecule. And guess what time it is? It's time to take a break. I'll see you at 2:55. I'm gonna get up and stretch. I'll see you in 5. Let's try that again. Oh no, I'm late. Sorry about that. I was thinking about something and time just went zoom. I'll go an extra hour so you don't feel ripped off. No, I won't. All right, let's get back to the problem set. And I was going to talk about or give you a practice problem with oxidation of a primary alcohol. So I better do that. And here's one for you to try. Give the organic product or products for the following reaction, 3 points each. Oh, we got a full house today. Not a full house, a lot of people. How did a lot become 5? I think we have the closed captions from the Twilight Zone. Do 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 do. Uh-oh, it doesn't do laughs. And let me know, give me a thumbs up when you're done. Well, I see one person. Let's see if you like the poll better. All right, I think everybody's done, so let's get to work. What do we have that's different? What's not carbon? What's not hydrogen? Ooh, oxygen with a hydrogen and carbon with carbons here, primary alcohol. I'm oxidizing it. And what do I get for this chapter? You get a carboxylic acid. If I were to put this on a final, which I probably wouldn't, I could also accept aldehyde. But for this test, you should have a carboxylic acid. And what's my R group? This. So I have these carbons attached to this carbon right here, which will be attached to that carbon, which is my carbonyl carbon of my carboxylic acid. There's 4 bonds to carbon. And that's the product you get. Now, on test 3, like test 2, I'll have a couple syntheses. You looked at the problem sets, I don't have any. Why not? Well, take any answer sheet, cover the starting materials, and you've got your synthesis problem. All right, but let me give you one. And here's one for you. What would I oxidize to make that product? And when you're done, don't forget to vote. All right, time for me to get moving. But before, I'm going to test the transcript. Nope, doesn't do sounds like that. All right, let's do this. What do we have that's different? Carbonyl, hydroxyl group. Remember, look for what's different, what's not carbon, what's not hydrogen. Should get your attention like this. Anyways, and we have carbons on the carbonyl carbon here, which is this one right here. And what do we oxidize to make that? And the answer is a primary alcohol. Notice the carbonyl carbon becomes this carbon here. We have 1, 2, 3, or otherwise saying that's my R group, 1, 2. I have this carbon here, which has the hydroxyl group. I know there are 4 bonds to carbon. And if I get my brain back in between my ears, I'll get it right. And there we go. Let me rewrite that. And there we go. And now let's get back to the problem set. And I have some oxidation of aldehydes. And now the next one. And here, what do we have that's different? Ooh, magnesium bromide on a carbons. And that's a Grignard, RMGX. I don't have it here. No, I don't. X can be chlorine, bromine, or iodine reacting with CO2, carbon dioxide. Excuse me. Second step, water and acid, or acid and water. And you get a carboxylic acid that's 1 carbon longer than the R group you started with. 2, 3 carbons. Cyclohexane ring is the R group. Put on the carbonyl with the OH, you get that. And I do some others. All right, next we have, carboxylic acid, sodium hydroxide, and I have water there too. And what do we have? Carboxylic acid, base, acid base, lose the proton, make the carboxylate anion. M can be lithium, sodium, or potassium. Li, Na, or K. And here it's sodium hydroxide, and everything stays the same. You lose the proton here, and you get the salt. Now, as I mentioned before, and I'll mention again, I'm going to always show charges. You don't have to. This is my preference. And D, oh no, I made a mistake. That should be carbonyl O minus Na plus, not the H there. Oh, bad mistake. Next, now this is important. Read the instructions. Draw the condensed structures for all of the product or products for this reaction. What do we have? Carboxylic acid, baking powder, sodium bicarbonate. You get the carboxylate anion, carbon dioxide given off as a gas. That's what the arrow up means, and water. So if R is methyl, it's sodium acetate, water is CO2. If R is this big fancy R group, you get this carboxylate anion, water, CO2. Now, 6A, knock off. I don't know what, 6B, knock off. Just eliminate, it shouldn't be on there. Yeah, Dr. White. All right, let's look at C, D, and E. They're all the same reaction. Just the R and R groups have been changed. Ooh, I was just going to do a generation gap. Any of you ever see the program Dragnet? When I was a kid, it was a very popular TV show. And they'd always start, the names have been changed to protect the innocent. Well, the R groups have been changed to make you learn more. Oh, generation gap thing that one didn't work. All right, what do we have? Carboxylic acid, alcohol, carbon with hydroxy group, acid catalyst, make an ester. Here's R, here it is. On the oxygen, you get R prime. The carbon with the hydroxyl group in R prime is the carbon that will be attached to the oxygen in the ester. The carbon in the hydroxyl group with the hydroxy group in the alcohol will be this carbon in R prime in the ester. And here I have an isopropyl, R is benzene, I get this ester. Now, if you take an ester and react it with base and water, and I have it like this, but a better way of showing the general reaction is like this. Where M can be either of these elements in the base, sodium hydroxide, lithium hydroxide, or whoops, or potassium hydroxide. And what you get back, because you're in base, you don't get the carboxylic acid, you get the carboxylate anion of the carboxylic acid plus the alcohol you would have used to make that. The carbon with the oxygen R prime is the carbon with the hydroxy group in R prime in the alcohol. So if we go and look at one of these, and I would recommend you look at them all if you have the time. And if we look at H, I made a mistake. And here R is the benzene ring with a methyl, R prime is ethyl. You get this carboxylate anion, but where I have Na plus, that should be K plus, oops, and R is ethyl. Let's see if I got this one right. All right, new reaction. You take a ester, react it with acid and water, you get back the carboxylic acid and the ester you would have used to make, and the alcohol you would have used to make that ester. And here, R prime isopropyl, R 3 carbons N propyl. Here's my carboxylic acid. The carbon with the oxygen bond to it in R prime is the carbon in your alcohol that will have the hydroxyl group. And the next couple, I just make fancier R groups or larger ones. All right, now I forgot to put the 2, but I corrected on the answer sheet, and I'll try and remember on test. If you take in D an ester and react it with not 1, but 2 molecules of a Grignard, second step, acid and water, you get 2 products, 2 alcohols. One of them, you make not 1, but 2 carbon-carbon single bonds. And the other, usually you have R prime small, so you can distill it off, remove it easily. And here, remember, keep your eye on the carbonyl carbon. That's where the fun is. The R group is still there. You lose the OR to the alcohol. And if we look at D, R is the benzene ring, R triple prime is methyl, R prime is methyl. Notice on the carbon with the hydroxy group, the benzene ring is still on that carbon. 2 methyl groups from the Grignard, get an alcohol, and the other alcohol, R prime is CH3, you get methanol. And if we look at E, same thing, R is ethyl, R prime ethyl, R triple prime is 4 carbon, where the second carbon has the Grignard that's attached to the carbon with the ethyl and the alcohol. And you make this very, very complex alcohol plus this simple alcohol from R prime. With this reaction, I will never, ever put a synthesis problem. That's cruel, unusual punishment. That's not nice. And with that, I'm done with the problem set. Any questions on carboxylic acids or esters or carboxylate anions, nomenclature or reactions? Remember, we're speeding up. Make sure you keep up. Do the problem sets on your own. I was talking to my other class, and I was thinking, when I was a undergrad student, it was worse when I was a grad student, you spent more time. I remember someone telling me, an instructor, or telling the whole class, not just me, that you should spend in fall, winter, at least 1 or 2 hours a week studying for each credit hour of a class you're taking. This is 5 credit hours. You should be putting in, each week is like 2 weeks. You should be putting in 5 to 10 hours a week studying if you want to do good in here. Got to put time in. By the way, a number of years ago, I went to my fraternity house reunion about 10, 15 years after we all graduated. And we're sitting around talking. Some of the brothers I knew when I was still in the fraternity house showed up. And we were talking. I said, wow, we really partied hard. And we did on Friday night and Saturday night. And the others started laughing. I said, what's so funny? And they said, you were always studying Monday through Sunday through Thursday, even Friday and Saturday sometime. I said, yeah, I was a chem major. All right, give me a second while I close something, maybe a couple of seconds. All right, we're talking about amines. And amines are where you have ammonia, where you replace the hydrogens with R groups. And this is a primary, I'll never ask on this test, secondary and tertiary amine. Now, since amines have non-bonding electrons, you can also bond on the nitrogen to that, unlike carbon. And you can also have quaternary ammonium salts. And as I mentioned last week, I think I have 7 patents in here. I work for a company that was one of the largest manufacturer of quaternary ammonium salts in the world. I call it manufacturer became sales. Wow. Anyways, how do you make amines? Well, let's look at the following slide. It's a little busy. Let's look at this first reaction. Let me take you to my whiteboard. If you take an alkyl halide plus ammonia, NH3, X equals chlorine, bromine, or iodine, and you react it in the presence of base, like sodium bicarbonate or sodium carbonate, this will attack, it's called a nucleophilic attack, the carbon with the halogen, and you'll get a primary amine. The X and an H becomes an acid, which is neutralized by the base. So let's take a look at this. If we look at this, the question is what's the organic product or products? And we look what's different, carbon, carbon, ooh, halogen, chlorine, and X here can be chlorine, bromine, or anybody looking at the transcript, it's wild. Anyways, chlorine, bromine, or iodine. And ammonia, NH3. This attacks that carbon in the presence of base. You get a primary amine. Remember, primary, secondary, and tertiary means there's three bonds to nitrogen. And therefore, what's my R group? This. Which carbon has the nitrogen? That one. Do you break carbon-carbon single bonds? No. And there you go. You get a primary amine and propylamine. Your turn. Oops, I forgot. I should print, not write. I heard the other day, you can tell somebody from my generation when they're doing a shopping list, they don't print it, they write it. All right, your turn. Give the organic product or product for the following reaction. And while you're doing that, on a personal note, because I gave this class and the other class a test last Thursday, I knew I'd be swamped this weekend with stuff to do, and I didn't have a chance yesterday. And I knew up front to let him know. My best friend lives in Highland Park, and I didn't go there. And if I had gone, we might have gone to that parade. Who knows what had happened? Sad what's happening in this country over guns. That's my personal opinion. No, not video, opinion. And please be patient. I try and give everybody time to finish. All right, I'll give you another 18.7 seconds. All right, let's do it. Look at this molecule here. What's different? What's not carbon? What's not hydrogen? Ooh, bromine on a carbon, alkyl halide. X can be chlorine, bromine, or iodine. And we have ammonia and H3 in the presence of base. And what do you get? You get a primary amine. Remember, 3 bonds to nitrogen. And what's my R group? Isopropyl. The carbon with the halogen, 3 carbons, because you don't break carbon-carbon single bonds, will be the carbon with the ammonia. And that should be a 2. Let me make it clear. And there are 4 bonds to carbons, so I can put in hydrogens. And I made isopropyl amine. Now on test 3, like test number 2, I will have some synthesis problems. And the question is, what do you react with ammonia and base to make that molecule? Your turn. And be careful out there today. It's hot. And make sure you're getting all your electrolytes like salt in your diet if you're out and perspiring a lot. I tell you, women perspire, men sweat. If you're done, don't forget to vote. All right, I think everybody's done, so I'm going to get to work. If we want to figure out what is the starting material that reacts with NH3 ammonia in base to make this, we look what's different. Ooh, nitrogen. Remember, what's not carbon, what's not hydrogen should get your attention like that. And I have a primary amine. This is my R group. What do I start with to make a primary amine? An alkyl halide plus ammonia in the presence of base gives me a primary amine. I'll never ask what's a primary or secondary amine, but I'll use terminology in class. So the carbon with the nitrogen is the carbon with the halogen. And you can have either chlorine, bromine, or iodine. Since I don't indicate anything here what it would be, your choice. I don't know, I'm in the mood for bromine right now. So I have 4 carbons, that's my R group. The N carbon has my NH2 group, and therefore that's the one we'll have the halogen. You could put iodine or chlorine there too for this problem, and there are 4 bonds to carbon, and I'll put it in my hydrogens. And that's how you do it. Now that's how you make a primary amine. And this is called nucleophilic attack because the carbon with the halogen, this one, is slightly positive, the bromine is slightly negative, and the electrons are attracted to that carbon and kick out the bromine. Guess what? On the primary amine, there's still a lone pair of electrons. So let's look at this reaction. By the way, that should be subscript. Oh, I have this from my software. But anyways, if we take a primary amine, react with an alkyl halide in the presence of base, you get a secondary amine. Let's look at the whiteboard. Remember, R and R prime are just carbon and hydrogens, just like X and Y are numbers in math. And again, the lone pair electrons attack. I tell you, organic chemists are violent. We are. And what you get is kicks out this and a hydrogen, get an acid that's neutralized by the base, which I don't show. And you make a secondary amine. So if I take this molecule plus this in the presence of base, and what happens? This attacks that carbon, kicks out the halogen. And what is this? This is a primary amine. This is, halogen on a carbon, alkyl halide. X can be chlorine, bromine, or iodine. This attacks that, like I said. And the carbon with the halogen is the carbon in R prime bonded to nitrogen. And remember, in amines, there are 3 bonds, 1, 2, 3 bonds to nitrogen. So this is my R group. This is my R prime, R, NH, R prime, carbon with the halogens bond to nitrogen, and that's this carbon. And you made methyl ethylamine, or I did. Oh, it's time for you to have some fun. And have fun. Give the organic product or products for following reaction 3 points each. Well, good news, we're on track. The summer's been fast paced. And whenever I teach in the summer, my greatest fear is to fall behind because it's hard to catch up. Anybody remember ketchup has a carboxylic acid, which is acetic acid from the vinegar? In the transcript, it says a carboxylic acid was something from Catholic. I'm not bringing religion into here. What the transcript translator does. Thank you, whoever asked to turn it on. It's funny. Hope it helps you though. Anybody happen to look at a box of fabric softener or bottle, think that has quaternary ammonium salts? Remember, that's near and dear to my heart. So I made a lot of money when I worked in the chemical industry at one company. All right, let's get going so we can be on time for our break. And if we look at this question is what's different? What's not carbon? What's not, ooh, a nitrogen here with carbons, and that's a primary amine. And we're reacting with carbon, 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 ooh, bromine, alkyl halide. That's going to be chlorine, bromine, or iodine. Look, bromine becomes romaine. No, we're not doing lettuce in this class. And in the presence of base, this attacks the carbon with the halogen and forms a nitrogen-carbon bond. Remember, there's 3 bonds to nitrogen amines. And what's my R group? 2 carbons. What's my R prime? 4. Carbon with the halogen, it's a carbon bond to nitrogen. So I have 2 carbons, nitrogen, and 4 carbons. There are 3 bonds to nitrogen. And I put a hydrogen there, and I'm done. And we made N-butyl ethylamine or ethyl N-butylamine. With that, why don't we come back? I actually went a minute into our break. Sorry. Let's come back at 3:51. And I'll see you in 5 minutes. I can get up and stretch again. Let's get going. All right, we're talking about making amines or synthesis amines. And amines, you'll see later in the chapter, play an important part in our daily life. And this was the reaction we talked about. And let's try a synthesis one. Ooh, hold on. I just thought of something that I should do. And the question is, what two things do you react to make this molecule? Now, what I thought about that I have to train you with, which practice makes perfect, this molecule here can also be drawn like this. And this is something you should get used to, because more likely on a test, I'll put this, not this, because this is less work for me to do, and organic chemists are lazy. Your turn. What would be the two things you react to make that molecule? And the votes are coming in. And it looks like I think everybody's done, so I'm going to get started. The question is, what two things do you react to make this molecule? What's different? Nitrogen. And it's got two R groups on it. In this case, R and R prime are the same, methyl. That's how you draw it this way. And what do you react with base to make a secondary amine? A primary amine plus an alkyl halide. And X, since I didn't tell you, can either be chlorine, bromine. The closed caption likes to put down romaine for bromine. Oh, got it right. I'll have to enunciate my words better. And therefore, what's R and R prime? Well, in this case, or up here, they're both methyls. So immediately I can say R is ammonia, methyl on this primary amine. R prime is a methyl. Pick your favorite halogen. I haven't used chlorine in a while. And the presence of base, that's what you'll make. And don't forget, on test number 3, there'll be 3 or 4 synthesis problems. And if you need practice with this, go to any of the practice problem answer sets, hold your hand over the starting material and say, what would I start to make this product? The answer. And you've got your own synthesis problems. Now, finally, on this slide, if you take a secondary amine, and react it with an alkyl halide in the presence of base. Oops. Time to close everything down and open it again. I've got the memory to increase on this machine, but I want to wait until after the semester is over to pop it in case I have any problems, because I want to be able to go online. And therefore, all right, we did this one. And let's go back to this. And we're right here. If you take a secondary amine, sorry about that, and react it with an alkyl halide, the presence of base, you'll get a tertiary amine. And remember that I've got to show this to you so you can see it. Now you can see it. If you have a secondary amine, alkyl halide, in the presence of base, you'll make a tertiary amine. Remember, 3 bonds nitrogen, which is why there's no hydrogen on that nitrogen. Let's look at it on my whiteboard. Again, nucleophilic attack. attacks the carbon with the halogen, bonds to that, and loses H plus this X, which is neutralized by the base. And you make a tertiary amine. And if I do this one, and if you do the reaction, the question is, what's the product or products you get with this reaction? Well, let's identify what we have. Ooh, this CH3 in a bracket with 2, that's a secondary amine. It just so happens methyl is R and R prime. Carbon, carbon, ooh, halogen on a carbon, alkyl halide. And remember, X can be chlorine, bromine, or iodine. And the presence of base, you get nucleophilic attack, lose HX, which is neutralized by the base, and you get a tertiary amine. Now, if R prime and R double prime are methyl, or R and R, it should be a single prime, then R double prime is isopropyl. The carbon with the halogen will be the carbon bonded right here to the nitrogen. So I already have on there 2 methyl groups, which I can write like this. They're still going to stick around. And then my nitrogen will be bonded to the center of 3 carbons. Now, on a test, you could write it this way, or if you really wanted to, let me give myself a little room here. This right here, you could have also written like this. 2 sides have methyls, and 1 side has isopropyl. It doesn't matter which is which. And these are the same molecule, dimethyl isopropylamine, which means I better give you a chance to do something. And it's your turn to do something. Give the organic product or products for the following reaction. By the way, that's not a benzene ring, it's cyclohexane. I just thought of something that I shouldn't have thought of. And that's why I did oi. You can't do oi or oi vey. Oh, it did. Sort of. While you're doing that, I'm going to play with the translator here, where the rain in Spain falls mainly on the plain. Ooh, it did it. Remember, next Monday will be test 3. I think sometime, hopefully tomorrow, maybe if I have time, for sure, before Thursday class, I will post the points breakdown for test number 3. And what's this on? All right, let's get going. And if we look at this, the question is, what's the product or products for following reaction? If I look at this first thing, what's different? Ooh, what's not carbon? What's not a hydrogen? A nitrogen. As a methyl group, I can call that R prime. And a cyclohexane ring, I can call that R double prime. You can switch them between R prime and or R and R. Hold on. Let's call that R and R single prime. And we have a secondary amine. And we're reacting, ooh, carbon with a halogen and alkyl halide. X can be chlorine, bromine, or iodine. And in the presence of base, this attacks the carbon with the halogen and forms a tertiary amine. And what's our triple prime or double prime? Methyl. So one way I could write this product is this. Another way you could also write it, both would be correct on a test. Notice I have 2 methyl groups on the nitrogen, and I could write it like this. Now, one of the things I haven't done today yet that I should, and I'm going to do it now, is I've been doing the last couple week or two saying, you should be asking the question, why am I learning this stuff? Well, the obvious answer is you want to get a good grade because someone said you have to take organic chemistry to get into school or a program like nursing. But why are you learning this? Well, let's look at the reaction you just did. And what do we make? Dimethyl cyclohexylamine. This right here. Now, this has a trade name. It's not an IUPAC or common. It's a trade name. And that's polycat 8. And the reason earlier I went oy vey, I was thinking I used this stuff in 1983, and that's almost, 40 years ago. I've been doing chemistry a long time. Now, what is this name? It comes from polymerization catalyst, and notice we've got 8 carbons. 1, 2 plus 6, 8. And I'll teach you later, polycat 8 is the catalyst used to make urethane foam to make things like the insulation of your refrigerator. If you look at old refrigerators, they're super thick because they use glass wool. Newer refrigerators in the last, since the 80s or maybe even earlier, are thin. Why? Because the insulation is now urethane foam, and you need this catalyst to make that, and you learned how to make that catalyst. So these reactions are used to make molecules, products that are used in our daily life or used by people to make products that we use in our daily life. And with that, if I look at the clock, oh no, it's lab time. It's a Tuesday, which means it's lab time, which also means I better open up the lab. Let me move this out of the way. Close this. Close this. Move this down here. Does everybody see carboxylate anions and esters on your screen? Give me a thumbs up. Thank you, Jimmy. All right, today's lab deals with carboxylate anions and esters. What is an ester? Carbonyl with an R group, oxygen with R prime, ester. And how do you make esters? Pay attention. You take a carboxylic acid and react it with an alcohol in the presence of acid. Now, H+ I've used for this class. For this lab, if we were doing it face-to-face, the acid is sulfuric acid, which is a dangerous chemical, which why I have concentrated sulfuric acid is corrosive, reacts strongly with water and clothing and your skin, and especially your eyes. So we should always wear eye protection. When we do this lab, all students, and the school provides them, wears rubber gloves. I ask all students to wear either a lab coat or long sleeve shirt or top. And years ago, when I was teaching at the other school, I had a night school. I got there about 4:30. Summer like this, it's 95 outside, and humidity is just bad. I'm wearing a long sleeve top. You wouldn't believe the looks I got. Like, is this guy crazy? Well, it's to protect your skin, and the students have to wear to bring lab coats or change once they got in the building. I did. All right, let's talk about this lab. Now, what are esters found? Esters are found in the causing the flavors and smells of many things in our daily life. And part A, you'd have two test tubes, big test tubes. And in one test tube, we put 1 milliliter of ethanol and alcohol. In the other test tube, we put 1 milliliter of 3-methyl-1-butanol, also known as isoamyl alcohol. That's a common name I didn't ask you to learn. Now, we tap it a little to mix it, and then we would add also in this, I forgot to mention, each of the test tubes have 1 milliliter of glacial acetic acid. The term glacial means pure, like an iceberg, a glacier. And I guess that's where it came. And acetic acid, you should know, has this structure. So what we're doing is this reaction in one in each test tube with a different alcohol. And we'll make this, it's called an acetate ester, depending what R prime is. One case it's ethanol for ethyl group, another it's the isoamyl group. And then I asked the students to smell it. Unfortunately, and Dr. White's sad right now, this is a fun lab to do face-to-face. Dangerous, but fun. Now, notice in here, I ask you to draw the ester form. Acetic acid ethanol makes ethyl acetate. When the students smell it, they say, wow, that's nail polish remover, which ethyl acetate is. Now, the second one with isoamyl alcohol, and you make isoamyl acetate, that's the common name, students have trouble with this. And what I do is say, think of something yellow, yellow. And I do it a couple of times to each group. All of a sudden, someone says, banana? I said, yeah. And they say, it doesn't smell really like banana. What does it smell like? And usually people say, well, it smells like the banana flavor Laffy Taffy. I don't like banana, even though I like the lab. I don't like bananas. This is one of the few fruits I don't like, but I don't. But anyways, why do they have trouble smelling that it's banana? And I teach them this. And what I teach them is when you have a banana, just a little bit of that ester, isoamyl acetate, gets your nose, which is very sensitive to smells. Mine is, even though I was a smoker for years, gave it up luckily. And you only get a small amount. Now, in the banana Laffy Taffy, they put a lot of the banana taste and smell, so you're getting a lot. In that test tube you smell, the way we do it is we don't smell the test tube. We put it in a beaker over some ice, and that cools it down, plus it's safer to smell. And I'm saying from that beaker, you're getting a ton of the ester, and that's why you're having trouble smelling it. Then I ask the next question. Have you ever wondered where artificial flavors come from? Making esters, now you know. We make esters in chemical plants that are food grade, used for that. Now, in part B, we have a different carboxylic acid, salicylic acid. We reacted with methanol, that's my alcohol, and add the acid and make an ester. And I ask you to draw that ester. And when you smell it, that methyl salicylate smells like mint, or more importantly, like mint lifesavers. And students are, wow, this is amazing. And that's why I'm sad you're missing out on this. Now, the last ester, part C, again, we take the acetic acid. Glacial means pure, 100%. The vinegar you smell is only 4%, roughly. This is 100%. You don't want to do like that because it'll knock you off your feet. I warn students about that. We add 1.5 milliliters of this alcohol, 1 octanol, mix it, make the ester, and we make octyl acetate, which I'm not asking you to learn, but you should know how to draw the structure. And that's a key ester that makes an orange and other fruits smell like it does. It smells fruity, or really, if you do it right, wow, that smells like an orange. And students are always amazed. All right, the second part, Dr. White has some fun because I know the chemical industry. We talk about a carboxylate anion, a very special one that's polysodium acrylate. And it has this structure. And this is a polymer where this is a repeating unit, like a long freight train with the same boxcar over and over and over again, where N is on the order of 1,000,000. Now, turns out this carboxylate anion can hydrogen bond to water. And that means it sort of bonds, not a chemical bond, but it helps stick to water. And what I show people is the chemistry behind one, super absorbent diapers. I don't have any at home, but actually, if we were at ECC, Dr. Daly does a great job as the lab manager, had years ago when I started doing this lab, bought me the diapers. Have you ever seen the diapers that are super thin, super absorbent? Well, it's not just cotton. If you open it up, there's a fiber, but there's all these white particles in there. And that's that polyacrylate. and that's the super absorbent polymer, also known as SAP. And I actually consulted for the company who discovered that. I didn't, but I had some questions and had me in to help them out. And at that time, before their patents ran out, it was a multi-billion-dollar worldwide industry. How many of you, and I'm not trying to get personal, but think about, have ever seen the personal care products for women for that they use that time of the month? And they have some that are super absorbent, super thin. And when a woman has her period, what's the liquid that you want to absorb? Mainly water. And guess what? Those personal care items that are super absorbent, very thin and tiny, use the same polymer. Now, what we do in this lab is to find out something interesting about that polymer. We actually have it pure. And what you do is put the sodium polyacrylate in a beaker, weigh out some, and the second one, you weigh the same amount. In the first beaker, you put 5 milliliters of DI water, and you see it become this goopy, or it's almost a solid. It just hydrogen bonds to the water. Now, in the second one, the same thing happens. Now, in the second beaker, what you do is you take this and react it with hydrochloric acid, 1 molar HCl, till the pH is lower than 5. And what that does is, this is a carboxylate anion, a base acid. You neutralize it. To make this compound. And you look at the beaker and to see how does that affect how well it absorbs or holds on to water. And it turns out, now you'll see the data in a second, when you do that, it becomes liquid again in the beaker. Then I ask you to this same beaker, now add sodium hydroxide and water till it's basic. And here we have an acid, remember, carboxylic acid plus a base. I'll just use sodium hydroxide, and water gives you the carboxylate anion. And therefore, what you get is the carboxylate anion polysodium acrylate. Again, you started with this, change it to this, brought it back to this. And if you look at the water in that beaker, it becomes all thick and viscous and goopy again. And if we scroll back down, you'll see, and I have better terminology, in both beakers, when you add the polyacrylate, sodium polyacetate, that should be acrylate, not acetate. Well, maybe. Well, anyway, sodium polyacrylate becomes a gel. This you just keep the same. Beaker 1, beaker 2, when you add the acid, becomes a liquid. And when you add the base again, becomes a gel, because it's undergoing this reactions. This is when you add the HCl, which is really H plus acid, and it forms the carboxylic acid. When you add base again, it forms the carboxylate anion. And obviously, when it's a liquid, it's not hydrogen bonding well to water. When it's a gel, it is. I'll say that again in slow motion. When it's a liquid, it's not hydrogen bonding well to water. When it's a gel, that polymer, SAP, is hydrogen bonding real good to water. And here's some questions for you to do. Don't forget, this is due this Thursday, but I also give you a window to be a little late. Get the labs in. if I look at the clock, and usually lab day, if we're face to face, we get out early. I'm done. With that, I'll say, don't forget, tomorrow's an important day. I'm going to go through a lot of amine chemistry, finish up that chapter. On Thursday, I'll do the amine problem set. Yes, speeding up, but it's the end of the semester, and that does that in the fall and also winter semesters. And with that, I'll say, gang gesund, be healthy. I will see you tomorrow. Bye.